Hello, in this section we will learn about how to convert data type and about the structure of VHDL coding. First, I will talk about how to convert data type together and how to write the main structure of VHDL, including write entity and architecture and generic part. First, assume we want to convert from integer to unsigned using numeric std. We should use the function to underline unsigned. The inputs of this function are including first the signal or variable with integer type, and the second input is the length of output or output of with unsigned type. To convert from std logic vector to integer, we have to use two underline integer parentheses unsigned, and between two parentheses you should write the input or input type of std logic vector. Also, to convert from std logic vector to signed, the converter function is signed. This slide shows different examples for each conversion. Unsigned function is used to convert from std underscore logic underscore vector to unsigned. Also, to convert from signed to integer, the function is to underline integer. Also, if we want to convert from signed to std logic vector, we should use std underline logic underline vector. And the unsigned function is used to convert from signed to unsigned. This slide shows different parts of VHDL coding. This picture has been arranged based on the order of each portion of VHDL coding. First of all, you have to write library as described in the previous section. Next part is the entity. The entity is including generic and ports. And the third part of VHDL is architecture. The architecture contains the declaration of signals, components, port map, and process as well. The process is including variable and process part that works by clocking timing. We also call the yellow part of architecture as a concurrent part, and the process portion is a sequential part. We will learn each part of VHDL code in this next slide. Generic statement. The keyword generic is used to declare generic parameters which can be used through the VHDL program. In this way, it becomes easier to adapt the VHDL program to different applications. The generic declaration are done in the entity part before the port section. You can see the syntax of the generic declaration. First, write the generic between two parentheses. You have to write the parameter names, colon, data type, and by this symbol, colon and equal symbol. After that, write the initial value. What is the entity? Entity part of VHDL program describes the input or output ports of an electronic circuit. A port can be an input port or an output port or both input and output port at the same time, or can be a buffer port. In the right of this slide, you can see the general structure of entity unit or entity for port. As you can see, write entity, after that the name of entity, after write is. In the next line, write port between two parentheses. You have to define your ports, the name of port, and declare input or output, and the type of port, STD logic or any more. And after that, write end. After end, write the name of entity. For example, if you want to write a port entity for the black box of the electronic circuit, as you can see, you have a input and one output, one input and output, and one buffer. So as you can see, write entity, my entity is, write port, and after that the port of one colon, the kind of port is input, so write in. After that, the type of port, STD logic. For the next one, the name of port is port name 2, and colon, the kind of port is output, and the type is STD logic. So write out STD logic. For the next one is in out. In out is it means both input and output. This slide shows an example for generic and port part of VHDL. So write entity, for example, the name of entity is example generic is, after that write the generic. Generic is top of the port. N and the type of this generic is natural, and the initial value is 8, and the second parameter is M natural, and the initial value is 16. And as you can see, the port, after that write port, and you can see two kind of port for input and one port for output. If the in or output or any port of is a STD logic vector, so you have to define the length of STD logic vector by n minus 1 down to 0. If I want to summarize the port part, each port name is unique and has an associated mode. Mode is input, output, and both in and out, and data type and size. For example, write a port entity for this electronic circuit. As you can see, we have two input, two output. In input 1 has 4 bits, and the second is 4 bits, so the type is STD logic vector, and with length 3 down to 0. and at the same as the input for the output. For example, input 1 and input 2, the mode is out, and SCD logic vector with length of 4 down to 0. This is another example for writing port entity for electronic circuit. As you can see, we have 4 modes of port like input, output, in, out, and buffer. Architecture. The architecture of a VHDL program describes the internal behavior of electronic circuit. The data received from the port of electronic circuit is processed inside of the architecture, and the output data is obtained. Then the output data is sent to the output port for each electronic circuit. You can see the general structure of architecture. Write architecture, after that the name of architecture, and after the name of entity, and then is after that declaration of the signals, after that begin, and between begin and end architecture, write the statements. I will give you some examples in the next slide. And after that, end architecture and the name of architecture. In this example, we want to write an entity port and architecture for this digital circuit. As you can see, we have 3 inputs and 2 outputs. All of ports are SCD logic. So write the entity, the name of entity is example 1. After that, write is port A and B and C are input, and the type of input is SCD logic or bit. F1 and F2 are output or bit or SCD logic. For writing architecture part, write architecture, the name of architecture of, then after that the name of entity or example 1 is, after that begin. To produce F1 and F2, as you can see in the picture, we have to do A and not B or C to produce F1, and so on for F2. This is another example for VHDL coding and kind of a complete of VHDL coding. So first of all, write the library. The library is in this code is IEEE.stdlogic 1164.all. After that, define the entity port. As you can see, Y, Z, and X are input, and F is output. To produce the architecture, as you can see, we have 2 signals, H and G, because they are not ports, so just for connection the input to output, so they are signal. After the architecture and before the begin, we have to declare the signals. Okay, and after that the begin, we have to define the operation for output. First produce H and G, and after that produce the output. In this example, we want to write a VHDL program for this operation. and we assume the input has 8 bits or a STD logic vector with 8 bits. Okay, so in this example, we want to produce two outputs, y1 and y2. To produce y1, we use the left shift logic, and to produce y2, we can use the right shift logic. In this example, we want to write a VHDL program that takes 2-bit vectors of lengths 5 and 7 and concatenate them together and send the result as an output. Okay, so the output have to be length of 12 bits, and for producing the output as described in the example, we have to concatenate two inputs together. To concatenate, we have to use the ampersand.